Hello, this is Harsha M, roll number 20E2509 from BSc Biotechnology, second year, and I have come up with a poster presentation on medical and therapeutic applications of radioisotopes. So, as we all know, radioisotopes are the unstable form of an element that emit radiation to transform into a more stable form. Now, this radiation is easily traceable and can cause changes in the substances that it falls upon. These special attributes make radioisotopes useful in medicine, industry, and other research areas. Since the discovery of radioactivity, a number of radioisotopes have been found that are widely being used in the field of medicine. The medicinal applications of radioisotopes are divided into two parts: diagnosis and therapy. If we look into diagnosis, we see that radioactive isotopes can be introduced in the body in chemical forms that have an affinity for certain organs, such as bone or thyroid gland. A sensitive detector called a gamma ray camera can observe the radiations from the isotopes that are concentrated in the organ and can produce an image that shows how the activity is distributed in the patient. These detectors are capable of determining where each gamma ray photon originates in the patient. Radioisotopes are also used to diagnose the nature of blood circulatory disorders, defects in bone metabolism, and to also locate tumors. For the study of circulatory disorders in blood vessels, radiosodium is injected into the patient. Another example is the detection of thyroid. When iodine is taken in the form of salt or any other substance into the body, it concentrates strongly in the thyroid gland, and an overactive thyroid holds it much longer than a normal thyroid does. If a patient drinks a glass of water containing iodine 131 isotope, the count rate in a detector placed near the neck of the patient 24 hours later immediately determines whether his thyroid is normal, overactive, or underactive. In fact, a similar technique is used to diagnose anemia. An anemic patient retains iron in the blood longer than a normal patient. So, by injecting a radioactive iron isotope and later by withdrawing blood and measuring its activity, anemia can be detected. Another notable radioisotope is radiosodium that has been largely used in medicinal research to study the action of various medicines. For this, a certain amount of sodium chloride having radioactive sodium in it is mixed with the medicine and administered to the patient. With the help of radiations from radiosodium, the circulation of the medicine in the body can be detected and hence its effects can be studied. Another technique that reveals a wealth of information is the PET scan, that is positron emission tomography. In PET scan, the patient is injected with a positron emitting isotope that is readily absorbed by the body. Examples of such isotopes are O15, N13, and C11. During a PET scan, you lie on a narrow table that slides into a donut-shaped hole. The scanner takes about 30 minutes to produce detailed image of the metabolic activity of the tissues and organs inside your body. It is often combined with CT scans to produce more detailed images. And PET scans are particularly helpful for detection of cancer and to determine how far the tumor cells have spread. And also it helps to check the status of your cancer treatment. Finally, one of the greatest therapeutic application of radioisotope is that these can be used in the treatment of cancer also. Radiocobalt and radiogold are mostly used for this. Certain cancers are treated by implanting needles or wires containing radium. The decays of these radioisotopes cause localized damage to the cancer cells. Other cancers can be treated using beams of particles that cause nuclear reactions within the location of the tumor inside the body. Pions and neutrons are used for this purpose. The absorption of a pion or a neutron by a nucleus causes a nuclear reaction. The subsequent emission of particles or decays by the reaction products again causes local damage that is concentrated at the site of the tumor, inflicting maximum damage to the tumor and minimum damage to the surrounding healthy tissue. Now, these were the major medicinal applications of various radioisotopes discovered until now. My presentation ends here. Thank you.